What point then do you just say, okay, we're going to list this company, we're going to go IPO?
We actually listed quite early on in our journey before we had that first proof of concept prototype.
Stroke is quite a prevalent issue.
You got millions of brain cells dying every minute. There's a very small window to get effective treatment. So we're developing portable brain scanners to reduce the burden of stroke.
Real disruptive technology is about accessibility at a fair price. I love medical device territory. I mean,
That's good. Well, ticker code's EMV, Mark.
Scott Kirkland, welcome to Going Public, mate.
G'day, Mark.
Very, very interested to talk to you about what you do. And by the way, just so by way of introduction, you're the founder and CEO of EMVision, as in EMVision, and your business is commercializing scientific research in Australia. But what's your background?
So my background specifically is sales and marketing. So I'm not the inventor or an engineer, but we've got some really talented engineers that work for us.
That's pretty important because when it comes to commercializing, you have to be able to market these things. Because the big issue is your engineers, they're great at building, designing, and then you have your clinicians who implement.
Yeah.
But you got to have someone to distribute.
Yeah.
So can we go through what you guys are doing now?
Sure. So we're developing portable brain scanners to reduce the burden of stroke. So specifically focusing on stroke initially. Two models. One is a cart-based system, so for the bedside, and the second is a helmet-based system for ambulances. And what we want to do is bring the brain imaging to the patient to speed up diagnosis, speed up treatment, because time is brain and stroke, right? The earlier you can do that, less disability, the better the outcome.
Stroke is quite a prevalent issue in probably everywhere in the world, but definitely in Australia. We all probably know someone who suffers from stroke. I certainly do. What have been the constraints around treating stroke or therefore the problem that you guys are addressing with the solution?
Well, 20 years ago, there were no treatments. It was a really poor state of affairs back then. Now there's really effective treatments, and they typically get blood flow going in the brain again, restore the plumbing, so to speak.
But that's what stroke is, isn't it? The blood stops flowing through the brain.
It's a blockage in a blood vessel in 80% of the cases roughly, but 20% can be a ruptured blood vessel, so a bleed.
Yep.
And so the treatments are different. So that's why you got to figure out what's the right type. So really effective treatments, the challenge is not everyone is getting access to those as early as, the healthcare community would like, because you need that brain imaging as part of the piece of the puzzle to help inform the right treatment. So if there's more widely accessible, low cost, portable, easy to use brain imaging, there's a good chance there's a greater percentage of the population that's going to access the treatment.
In terms of stroke, the first thing we've got to do is work out if someone has actually had a stroke.
Mm.
I mean, there are, I don't know, I hear it on the radio, they advertise it sometimes. There's some word acronym they come up with.
FAST. Face, speech, and then time. Time is up there. Good thing I remembered that.
Yeah, we could have edited it out and done it again. But time is the critical one.
That's right. Yeah, spot on. You got millions of brain cells dying every minute. I can't remember the exact statistic, but it's like, I don't know, every half hour, the brain may be aging about 10 years or so in the event of a stroke.
Right.
That kind of thing. So, yeah, there's a very small window to get effective treatment.
The same applies to things like concussion. The quicker you can stop someone or diagnose a concussion, in a footy game or some kid falls over, the quicker you can diagnose that and start treatment on it, the quicker the person can get better. In terms of what EMVision's solution is to the problem, can you go back a little bit and tell me about the history of how this all started?
Yep.
Like who was the dude who was sitting around thinking, well, this is a problem, we got to come up with a solution?
So we go all the way back to, I think it was like late 90s, early 2000s.
Oh,
There
really?
was, okay, I'll keep it short, but there was a research team.
I'm dying to know.
There's a research team at University of Queensland that were developing near-field radar to look at slope stability in mine shafts, trying to spot a crack earlier. And they developed this neat little system that they spun out into a company called Ground Probe, which was acquired by Orica, bigger player there. And so they had all these talented engineers that were looking for something to do. And Professor Stuart Crozier came in, who had a background in MRI innovation. So he developed IP that is now in most, 2/3 of all MRIs. And he thought this is a good opportunity to restructure the team and let's see if we can use this underlying technique of imaging to look inside the body. Right. And so that was, around 2008 that they began in earnest looking at imaging the skin, the torso, the liver, and the brain. And
we're talking about using an MRI machine?
No, it's called electromagnetic imaging on the microwave frequency or spectrum, and it's similar to the full body scanners at the airport. When you put your arms up and they send signals into your clothes.
Right.
Same kind of thing, but at a lower frequency going into the body. So I had a connection to the professors kind of 2015, 2016, and they were looking for funding to help progress those devices.
Right.
And I had an interest in the skin scanner specifically. My father had melanoma, and I thought that might be something that could have a positive impact. It's a big issue in Australia, right?
Yep.
Speaking with a bunch of dermatologists, there wasn't a lot of enthusiasm for changing what they do.
You mean at the clinical level?
Correct,
Yep.
correct. But so I started looking a bit deeper into the brain scanner opportunity and spoke with a bunch of neurologists, intensivists, nurses, and everyone said, we need this. There's a real need. Stroke's a big issue. It's like 1 in 4 adults will have one. We need portable brain imaging. So there was a genuine pull from the clinical community to take that forward.
You're saying the guy who invented this for the mind originally, it was able to be moved around, but might have been looking at cracks in the mine shaft or something like that.
Well, yeah, it was a similar underlying principle. So near field radar.
What does that mean?
Near field radar. It's rather than trying to find planes in the sky, it's trying to look at objects. They use non-destructive testing, use it in the pyramids, trying to find hidden chambers, those kinds of things. But let's use it to look inside the body.
Yeah.
That's kind of a layman's explanation.
Yeah.
That's why I'm in sales and marketing, not the inventor. It was that technique, but adapted for the human applications, but portable. The key principles were portable. So, a series of antennas, not requiring the energy that a CT does or the magnets that an MRI does. So we could send signals that are similar to what your mobile phone uses.
Wow.
Right. So there are trade-offs, of course. We're not going to get the same image with a $3 million MRI.
Yep.
But the idea is we could get this portable system that can deliver a good image so we can make quicker decisions when a time-sensitive medical emergency is occurring.
But in terms of stroke,
Yep.
and given what we said right at the beginning about that time factor, in terms of treating a stroke is not like a skin cancer that grows fairly slowly. If you get regularly checked, you can get on top of it. A stroke just happens.
Yep.
A lot of times there's not even any indicators. It just happens.
Yep.
And it happens. It
can happen to anyone.
And it can happen anywhere, anytime, at the worst time.
Yep.
Because I've got friends who have had strokes, and they all happen at weird times in weird places, and everybody panics. So you then thought that this is an opportunity or a problem that needed to be solved. What happened then?
Well, the first step was to secure the rights to take it forward. So that the research team, so it was Professor Stuart Crozier, Professor Minna Bush, and they had about 20-odd talented research fellows, PhD students. They were all very keen to take this concept out of the lab and develop a prototype that could go on patients, suitable and for a proof of concept. So they needed funding.
Usually that's at an academic level, like a sort of NIHMRC or government.
Correct. Yeah. Exactly. Yeah. So we pursued
national health research.
Yeah, that they're fantastic. They make a huge difference.
Hard to get though.
They are very competitive. They're pretty good at getting them at the unis. But for us, I think we've secured maybe 20 million in grants.
Wow, that's a lot though.
Yeah, yeah. And reason being, stroke, huge health economic burden. So it's about 6 billion or so in Australia each year. That's the kind of societal health economic cost. We can keep manufacturing local, create more engineering, STEM jobs.
Are you saying that you secured from the government though, 20 million?
Federal and state,
Oh, wow. And just explain though, what happens when they give you the 20 million? So do they take a share of the business? What happens?
No. So different schemes. So we've had the first one we got was called a Commonwealth CRCP. And that was, I think it was 2.6 from the government, 900 from partners, GE and the University of Queensland. And that was really milestone based. So you need to deliver on certain milestones, show you're progressing through the project to receive the grant funds.
But what do they get?
Well, they get, like I said, they're helping fuel innovation in Australia and job creation.
But they don't
get
any equity or
any
share of the IP?
No. The unit for us to acquire the rights to the IP, we gave the university a shareholding in the company and a modest royalty rate as well on the original IP.
Right. So you and your
and my co-founder Ryan Laws. Yeah.
Okay. So you discovered this professor who's got this bit of tech. You've worked out there's a need. You go back to the university where this professor comes from and then you cut a deal on the IP.
Correct.
Yeah.
With they've got a special division called UniQuest, which they do these deals all the time. Technology transfer deals.
It's not unusual for the University of Queensland to do this sort of stuff.
They got a great track record. They got like 100 successful startups. Yeah.
Right for things like solar and everything. Like they've been like leaders. In a lot of areas.
Yeah. Cervical cancer vaccine came out of there as well.
Right. Because most great technology starts off in the academic environment, but it does need commercial inputs.
Correct.
Because they don't know how to take a commercial.
Some,
most don't. My experience,
sure.
Most don't. I've been involved in one or two of them.
Okay.
Out of University of Adelaide, and my experience is they're great at the technology, but they're not great at raising money. And spending the money and convincing people actually to take risk.
They're not great at spending the money?
They're good. No, I mean, what I mean by that is they do spend it. I mean.
Oh, right. Okay.
Yeah,
they're too good at spending money.
They're too good at spending money is probably the way I should put it. Like in research, especially when you have engineers and what have you, they can tend to have a list of 20 things they want to do instead of saying, look, here's 5 things or 3 things. Let's just do those three things and let's not move outside those 3 things. Prioritization is a big deal because everything's interesting.
Yeah. Yeah, it's a really big danger. You got to do one thing, do it well. We could be looking at stroke, but Alzheimer's and 50 other things. We're trying to just do stroke and making sure the team's focused on that. Yeah. Going back to the commercialization expertise, Stuart Crozier again, because he'd done a deal with GE and Siemens and licensed out IP, that commercial nous gave us a lot of confidence as well that we're partnering with the right people to take this forward. We still needed to bring in medical device industry experts into the business with that commercialization expertise, but we knew the underlying, the co-inventor had a pretty good nous.
So the guy who invented it originally, was he an engineer?
Yeah, they're all engineers. Yeah, it was a big group.
The biomedical engineers.
Yeah. So some are experts at antenna design, transceivers, algorithms. It's
because there's a lot of software goes into it.
Huge amount. Yeah,
and but there's also a lot of industrial design, mechanical design, mechanical engineered, electrical engineered.
Yep.
There's a whole host of engineers who have to go into design.
It's got to be easy to use.
Yeah, it's got to look good. It can't look too scary, or cumbersome, or it's got to have a certain industrial look about it.
Yeah.
So you and your co-founder, you're sitting there looking at this great technology. You've got a problem to solve. You've got the technology to solve it. Where to from then? So let's say you've reached your milestones. You've built a prototype. I presume we're getting to a prototype.
Yeah, we're getting to a very agricultural prototype, but one could go on healthy volunteers. And I remember getting scanned back in the lab back in 2016, I think it was 17. And so the main thing was, okay, we've got to find talented engineers, product development people with industry expertise. That was the big kind of, we got the research team. We had a great industrial design team through Tiller Design. We needed to find the regulatory experts going through FDA, TG, making sure you're designing, developing something that's going to meet all those requirements globally. It's a huge, huge task. And again, there's a big difference between a research product, a research prototype that may be perfect in a lab. You need something that can work under all scenarios, all environments in the wild as well, right? And so sometimes you have to compromise on certain things to get it out there. The concept is get a minimally valuable or minimally viable product into market in a quick amount of time and then build on it rather than spending years and years and years doing R&D, trying to do perfection. And, you see a lot of things just never get out there because maybe we can tweak this a little bit. And then, So.
Because that's an important point. Yep. I mean, if we could just sort of sit on this for a second, I don't want to park it because often people who are coming up with and academics can tend to do this. If they're coming up with a solution to a problem, they can tend to try to perfect it. And the process of perfecting it usually runs out of capital pretty quickly. And capital markets don't stay available all the time. You've got to nail it while it's there. Mm-hmm. So that means you pretty much got to have a minimum viable product as soon as you can.
Get it out there, start making some money, and then you can build from there.
We'll show people will pay for it.
Yeah.
Getting it tested. Yeah. How did you find patients?
As part of that grant that we won, we were fortunate to bring in some clinicians from Princess Alexandra Hospital in Brisbane that were really enthusiastic, really supportive, could see it had potential to improve the stroke care pathway. And so very early on, they're making sure we're building something useful. And then you go through an ethics process, you design a study protocol. And because the device is non-invasive, you're not impacting anyone's standard of care treatment or slowing down any processes there, we could run a study fairly easily to get that that proof of concept. So that was a 50-patient study. We're now running a much larger study at the moment.
The prototype, how close is it to, does it look to the end product?
Yeah, I was just trying to think of an analogy. It's kind of like a hand-built kind of classic car. They've put out 50 of them. It does the job. You're not gonna build 1,000 like that. It's pretty similar. I mean, it has a headset. It's got brains that make sense of this, something called a VNA that measure all the signals we send. I think the big difference, our commercial product is a lot smaller, and it's designed to meet, international medical device standards, meet our margin objectives as well.
In terms of cost.
Exactly, yeah. So, but if you put them side by side, they're not worlds apart. These are portable brain scanners.
So at what point then do you just say, okay, we're going to list this company, we're going to go IPO, we're going to raise more money through the public environment?
Well, we actually listed quite early on in our journey. So it was even before we had that first proof of concept prototype for patients. We had a lab-based concept prototype. And I think that was a byproduct of where, you talked about the availability of capital, kind of 2018, there was appetite for R&D stage, innovation stage, if you had a story where there were some pretty clear milestones you could communicate along the way.
To your investors.
Correct.
How much money did you raise?
$6 million. So
okay.
At a very modest valuation as well.
I was going to say that $6 million in itself is quite modest. In terms of the amount of money you want to raise, you have to be clear in your head what the value of the asset is today, or the assets are today. And in your case, it's IP.
IP in the team.
And how do you do that?
It's very, very hard. And even fast forward today, we've got some research coverage from a few different brokers, and there's quite a lot of variance between their valuation expectations as well. So it's pretty hard. I think the main principle was making sure that there's enough upside for those coming in and not getting greedy. You see listings, my opinion, listings at a price for perfection, you're making it very tough for yourselves.
Yeah. So when you list and you raise $6 million, one of the main reasons you've got to have valuations so that you know how much you're going to give away. Because like the $6 million that you raise might represent 10% of pre-money $60 million.
It was a bit under 20 mil at that time.
Valuation. So you're giving away like just under a third, and the investors have got to be clear. Well, hang on, that 20 million, I'm getting a third. I'm getting my share of a third, to the extent that they're participating. Did you do a second round?
Yeah. So byproduct of those grants, we haven't had to raise a lot of money, which has been great. But
so you can get grants in the listed entity. The listed entity can also go and get grants. Okay, that's good.
So we did $4.5 million in 2019,
and an additional $4.5 million.
$4.5 million, and then we did $9 million in 2020.
And have they all been up rounds?
Yeah. So we listed at 25 cents. The 4.5 was at 74 cents, and then the 9 was at $1.40.
Oh wow, that's pretty good.
Yeah.
And in terms of knowing at what point to go to the market, how do you gauge that?
In the market, I think you really want to time it around meeting that pivotal next stage of development. We're starting a big trial or whatever it was. So I think
it's a big milestone coming up.
When we did 2018, we just built that device that we're going to take into the trial. And then in 2020, we just imaged patients, our first few patients, that kind of thing. So those kind of milestones, you've de-risked it, you're bringing in a new audience of investors.
And do you use the same book runners? I mean, or do you change your brokers? Have you changed brokers? Do you change brokers throughout the process?
We've had some brokers that have been following since the early days bid into the books along the way. We used Bell Potter in June 2020. They did a good job. I think there's the same principle as well with those placements. You make sure that, again, you're not asking for so much that you're going to be nervous around whether we get this or not. You set the amount you need to get your milestone. Don't get talked into doing too much. And then make sure, there's genuine demand well beyond what you're asking for, and then you can go through a process and figure out who are the investors we believe are going to be there for the longer term, and go through the filter.
Let's say you could raise 100 million for argument's sake. Is it better to take the money all as much as you're going to think you're going to need over the next 5 years now, or is it better to just take a little bit now, reach another milestone, go get a bit more at a higher price?
There's quite a few different views on this. If we use that 9 million example, we had maybe bids for 3 or 4 times that, rough, So there was opportunity to take more.
Right.
To
you
upsize
could have
it.
increased it.
Yeah. We didn't need it. We didn't want to overly dilute everyone. And I think that's worked out well because we haven't had to raise money for 3.5 years and still don't. So, I think in hindsight that has worked out.
How do you think, or your actions within the business as CEO change once you get into the public listed sphere?
I think it's important. When we first listed, I was an executive director, mostly focused on corporate development. So co-founder, executive director, and my colleague Rob Weinberger, who was the former CEO of Nanosonics, which is a successful medical device company. He was CEO, and so recently we did a transition. He's stayed on the board and as a consultant. I think corporate development, most of my time was focused on building partnerships, so clinical relationships, other grant opportunities, product partners, potential future commercial partners, all these kinds of things. And rather than, in the pre-listing space where you might be meeting investors every 6 months to give them an update, when you're listed and you're in small cap land, you firstly, you need to plan out what is the roadmap of meaningful developments we can communicate over the next 12 months, right?
And that's an important word, communicate.
Yeah.
Yes.
Yeah. You've got to keep people engaged. And I think if you're thinking about listing and you look at the 12 months and you think, wow, geez, there's not a lot to talk about. Maybe you want to, if you're in that pre-revenue space, you may want to reconsider because it can be very tough if there aren't, meaningful milestones to communicate. And you see that.
What about when there's bad news?
One of my colleagues, Ron, his favorite saying is, would you rather be Chris Charisma or Chris Credibility? Right. And his view, and I share this view, is if you're upfront and transparent with people, they'll accept it. So, for example, when we were running our first study, that was coincided when COVID became a thing. And trying to run a study when you've got a pandemic, that can be challenging. And there were times where we had to pause the study.
Yep.
And we didn't know how long that may be paused for. So but again, you have to communicate quickly. Obviously, you've got continuous disclosure obligations. I think if you're transparent, if you've built up a period of credibility with your shareholders, I think they're pretty accepting. They understand these things. The risk and return profile, it's going to be a roller coaster. It doesn't always happen to perfection. But I think we've been lucky in that we've been able to hit our major milestones over the 5 odd years or so that we've been listed.
You were able to raise money in an IPO. I mean, would you have been able to raise it, like just go around and do high net wealth or something like that?
I would think so, because the story is one that resonates with a lot of people. You mentioned, someone that has a stroke. A lot of people have that personal connection. A lot of people understand, have had brain imaging and appreciate, portable. That makes a lot of sense. We didn't go down the VC route, but again, it was we set up a public unlisted company from the outset. So we had a board, we had the governance structures in place. So transitioning from private to public wasn't a massive leap structurally for the company. But yeah, again, the window was certainly open. If we were trying to list our stage of business now, it would be very challenging.
Why do you say that?
There was appetite for companies developing innovative products, going after big markets that might not be generating revenue, but had good quality teams attached. There was appetite to support that. I think at the moment, you're not seeing a lot of listings in that space. You got to be profitable or pretty close to, yeah.
Yeah. So people's view, investors' view of what they're prepared to invest in, I think has changed post-COVID. Well, and I don't think it's got anything to do with COVID. I don't want to say that because it's got nothing to do with COVID. But I think it's got a lot to do with liquidity in the marketplace. So what return can I get on some money that I've got to invest? I'm an investor, say. Well, I can go and put it in the bank and I could probably buy some bank hybrids and I'll get 6%. Buy CBA hybrids, I can get 6%. Not bad. It's a bank. It's basically no risk associated with it, particularly CBA. They just make $10 billion profit. So it's pretty good. And I don't have to think about it. I'll get my money every month, every quarter, whatever it is, however they pay. If you go back 2 or 3 years when you were raising money, the return you got was like 0.5%. So there's a lot of liquidity looking for a home.
Sure. Yeah.
And so I guess part of your role is to assess liquidity in the market and what sort of asset classes are trying to attach itself to, and do we have the asset class in your case? Like, are they interested in medical devices? If the whole world all of a sudden says, we don't care about medical devices, it does make sense trying to list your company on the stock exchange because you're not going to get the investors. But if the whole world's saying we're really interested in medical devices and we can't put our money anywhere else because we're getting a crappy return if we just put it in the bank, do you think that's part of the reason why you were successful in raising money in the various stages you raised it in your business?
So it's a good question. I mean, it's part of this. Was it a timing?
Yeah.
Was it a timing thing?
That's the question. How important is timing?
And I think there's a class of investors, particularly family office, and we'll call them super high net worth, whatever you want to call them. We got a few on the register which have been very supportive. That probably they want to make money, but they also want to support something that could have a positive impact, and they're always around. So they might have still been there.
They're very sensitive to returns. When am I going to get some money? When am I going to get a dividend?
Sure.
You got to time those ones.
Yeah.
And who did you lean on or refer to get that timing part right?
There's quite a few different things. The broker, Ryan, my colleague, had, particularly the investors that supported us in the private rounds, they followed on, right? Yep. They wanted to support again. My colleague, Ron, he, as I mentioned, Nanosonics, there were plenty of people that backed him early on there.
Right.
And that's it's like a 14-year overnight success story, but that's, they went from 50 mil, there may be a 1.5 billion market cap now. So there's plenty that did well out of that journey. We're happy to back him again as well. So I think, and likewise, some of our directors, brought various people to the party. So I think there were quite a few different contributions bringing that investor pool in. And also a part of it is figuring out, it's not for everyone. So figuring out within that universe of small cap fund managers or family offices who likes the space, who's done well in the space.
That's where a good broker knows in his client list who likes this stuff.
Correct.
Where are you up to now? So in terms of your milestones?
Yeah. So we're running a much larger study at the moment, enrolling 150 suspected strokes. So we've got 3 of those first generation devices that I was talking about before, one at Liverpool, one at Royal Melbourne, and one at Princess Alexandra. And there's a couple of phases to the studies. Then we want to go to the FDA, TGA. We expect to be on market around FY25.
Ultimately, it's about manufacturing.
Yep.
Lots of them. Because you're getting orders from all around the world, let's say.
Big part of it is consumables. You got the device, but then there's a cap and there's a coupling media, which is single use per patient to create a reoccurring.
So it's one of those caps with all the wires coming out of it?
No, it's just infection prevention.
Oh, okay. Yeah.
But, we're targeting around $25 per scan for that. So you got the device itself targeting around $150K US, 25 scan, and then preventative maintenance and service contracts, about 10% of the capital equipment per annum.
Wow.
Right. So it's a large market. It's about where are we going to start? What are the areas that require it the most? Is it in the regions at smaller hospitals that might not have CT? Is it in tertiary large hospitals that have a packed ICU and need to monitor patients? There's a few different opportunities there. And think about it, the hospital as well. There's a huge demand to get in there, and they got to figure out who do we prioritize.
Yeah.
I mean, often it is stroke patients because of that time issue, but also trying to take someone down from ICU. If they're on life support equipment, they're on a ventilator, and you got to pack them up, take them down. That's a big trip.
So it'd be better to take the stuff to them.
Correct.
And that's
part of the proposition.
That's really your thesis.
Part of it, yeah.
We will bring it to you.
Correct, yeah.
That's pretty cool. The tech is not as innovative as the distribution of the tech. In other words, where I can use the tech.
Right.
That seems to me to be one of the most innovative parts of it, because you can put, as you say, you can put it in an ambulance, or you can take it to the
flying doctor
patient.
Service.
Flying doctor put it on the plane,
especially
to regional areas. I mean, regional areas would not be able to afford or justify a proper machine.
There's the stat. I'll give you a quick stat. So it's if you have a stroke in a metro area or in Australia, 77% of people end up in a stroke unit. In regional, it's 3%.
Wow.
Right.
That's
so
mad.
big disparity. A lot of people ending up with lots of disability in the regions.
Yeah, again, back onto that time thing, the time part of the formula.
If you're 2 hours away from the nearest hospital, you're
in trouble.
Yeah, and that hospital might not have all the gear to image you, and then they've got to send you somewhere else. And
that's mad. So that's just Australia, by the way. So we're talking. I guess you're talking globally.
Yeah, China. There's about 400 million people in regional areas.
Wow.
Yeah. So there's
some huge markets.
Yeah. Yeah.
And Australian technology, generally speaking, particularly in this area, generally speaking, is highly respected too.
Yeah.
Well, and I want to thank you for coming in here today to talk to me about going public.
Yeah.
And so well done.
Thanks, Mark.
It's been fantastic to talk to
Appreciate
you,
it.
Scott. Thank you.